All right, so we had a test Friday. These are the scores. Pretty good. I feel like transformation geometry is kind of an easy topic. Do you agree? The good news is we're going to keep doing transformation geometry for this unit as well. The last unit was all about transformations on a point, and this unit is all about transformations on actual like figures, triangles, quadrilaterals, or whatever. Okay, so particularly if you're on this half, that's great news. Okay, and this guy, probably not good news. Anyway, all right, so let's move on. So,
Are we still gonna have a quiz Wednesday?
great question. Yeah, we are going to have a quiz Wednesday, but it's only going to be on today's material,
Not tomorrow, just
not tomorrow's. Correct. So whatever we go over today, that's what the quiz on Wednesday is about. Thanks for asking. Okay. All right. So transformations of figures.
behind you.
And the good news is it works exactly the same as transformations of a point. Okay, so for example, suppose you have triangle ABC, where A has coordinates -3, 5, B has coordinates 1, 4, and C has coordinates 0, -2. They might ask you to find the coordinates of triangle A prime, B prime, C prime. The image of triangle ABC after a translation of 3, -4. So you could do this two ways. You could either graph it. So let me just show you how that would work. I would just graph the original triangle. So A is -3, 5. There. B is 1, 4. And C is 0, -2. There's the original triangle. And then you just look at the rule. The rule is saying to move this 3 units to the right and 4 units down. So you just do that for each point individually. So I'll start with A. If I move it 3 to the right and 4 down, it ends up here. There's A prime. B goes 3 to the right, 4 down, that's here. B prime. And C goes 3 to the right and 4 down, right here. C. And then just make sure that when you're done, you end up with a triangle that's the exact same size and shape as the original. If it doesn't look right, it's not right, okay? Because this is supposed to be, remember, a rigid motion or an isometry. It's supposed to look exactly the same as the original. Okay. Another way I could have gotten these coordinates is I could have just transformed each point individually, right? Just by adding component-wise. Like if I took the translation of 3, -4 of the point A, -3, 5. Remember, that rule is you just add the X components and the Y components to get the image, right? So this would end up being the point If you add these x components, you get 0. And the y, negative 4 plus 5 is 1. And that's where it ended up, 0, 1. This is going to be A prime. And we could have just done that for each point individually. If I took the translation, 3, negative 4 of the 0.14, same thing, just add. You get 4, 0. That's B prime. If I took the translation, 3, negative 4 of point C, 0, negative 2, this ends up being 3, negative 6. That's C prime. Okay, so that's kind of easy, right? That's the first thing. The second thing then would be reflections, right? We talked about translations. Reflections works the same way. To reflect a figure, over a line, just graph it. Just like you would if you wanted to reflect a point over a line. That's the best way to get the image. It's the best way to get the image in a reflection of a figure as well. Okay, so like for example, suppose I had a quadrilateral. So suppose this quadrilateral has coordinates negative 6, 2. Call that P. Q is negative 4, 5 right here.
What did you say Q was?
Negative 4, 5. R is negative 2, 0. And S is negative 5, 0. We have this quadrilateral. If they said, do a reflection across the line y equals x minus 1. Reflection across y equals x minus 1. Well, that's the line that has slope 1 and y-intercept negative 1, right? So it's going to be like this line. I'll do it as a dotted line. It's going to be this line right here, right? So this is the line y equals x minus 1. And you're just going to point by point reflect it across the line. That's it. Remember, to reflect across a sloped line, you go perpendicularly to the line, right? So like if this has a slope of 1, then from point R, I want to go straight to it with a slope of negative 1. So that ends up being like 1.5 diagonals. So I just go 1.5 diagonals. So R prime is going to be right here. And you just do it point by point. So S, if I go straight to S, that's 3 diagonals. S prime is going to be right here. Q, if I go straight to it, is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. This is going to be Q prime. And finally, P, if I go straight to the line, 1, 2, 3, 4.5. So there's a half, 1.5, 2.5, 3.5, 4.5. Ends up being right here. This is P prime. And again, if I graph it and it looks like it doesn't really have the same size and shape as the original, then there's a problem. But this looks pretty good. If you turn your head sideways, it's a reflection. Everything's all symmetrical. Looks good. Okay, so there's variations on these problems. So in some problems, they might on Delta Math, they might give you a line, and you have to like move the line until you figure out where the line is to go from here to there, for example. It might give you the original figure and the image and ask you to find the line of reflection. Or another one, they might just give you the two figures and ask you to do it a little bit more methodically. So the way you could do this methodically to get the actual line is you could just take a point and its image, draw the line between them, and then think about it. The line of reflection would have to be the perpendicular bisector of this line that connects those 2 points. Does that make sense? It has to pass through the midpoint, and it has to have a negative reciprocal slope. So you can find the equation of this line really methodically. If you had this whole figure and this whole figure, all you need to do is connect a point and its image and do the perpendicular bisector of it. So in some problems, they're going to ask you to do that. Okay, other problems, it'll be just like what we did here. They'll give you the line, they'll give you the pre-image, and you have to just plot points to find the image. Okay, so there's a couple different types of problems, but it's really straightforward if you just read the directions. So tonight's homework, that's what it's about. It's about translating a figure, like a triangle or a quadrilateral, and reflecting a figure over a line. And that's it. And that's what the quiz on Wednesday will be about. Any questions on that? Okay. So the homework, it's on Delta Math, and it's just called Translations and Reflections of a Figure.